Okay, so I'm going to put a couple of things on the board, and I want you to help me name them, right? Is that cool? And then if not name them, I want you to, so what are we going to name this first one? What is the name?
Would it, no, it wouldn't be that one.
Pernitrate.
What was that?
Pernitrate.
Nope.
It's ammonium carbonate.
Ammonium
Carbonate?
carbonate. That is correct.
She beat me by literally a second.
Okay, that's right. You can give me the chemical formula for the next one.
Let me see. I know lead is PB and hypophosphite. Wouldn't that? Huh?
Would it be PB3?
Well, no,
And
because that lead 4 means it has a +4 charge, right?
Okay, so she said PB3,
Yeah.
parentheses?
parentheses,
PO2.
O2.
That's what I was thinking.
PO2.
Yeah. Thanks,
And then
guys.
the 4 goes on the outside.
And then the
of the
4 go, yeah.
parentheses.
Job.
Oh.
Sodium tellurate.
Okay, Na2. And then TeO, oxygen. And then the 3.
That is correct.
So would this one be magnesium perchlorate?
Chlorate.
Magnesium
Perchlorate.
perchlorate.
Perchlorate, right? Okay.
That is correct.
Is this one chromium 3 phosphate? Oh, shoot, the other oxygen. Never mind. Never mind. Just kidding.
So you said chromium 3.
I missed that that other oxygen though. Hold on.
Okay, come on, somebody. Somebody can get this one.
You know, it's plutonium, right?
Polonium.
Yeah, that one. Sorry, I put a T
Yep.
in there.
So what would we call it?
Something.
We call it something. Oh, something.
It's. Would it just be the I at the end of it? I feel like that's wrong too.
Well, no, because that's Po. And are there oxygens there?
Yeah.
So then what do we know? If there's oxygens there, what should we be putting at the end of it?
Oxide.
No.
It's way too early, Dr. Henry.
Oh.
Come on. We've been working with these. What do we look at all of the other stuff that's up there. Oh, if there's a P, capital O, that makes it
8?
okay. So what I would call it, oops.
Oh, is that right?
Yeah, you're right. Come on, that's what we're talking about. Oxy acids, right? Or oxy anions, not anacids. Oxy anions. polonate,
Poloniate. Okay.
right? Because it asks for, just like, isn't polonium? Where's polonium located at? Here, let me switch sharing.
It's located right here.
It's located right there. Under what? Is it under sulfur? Group
No.
16?
Oh, yeah. Yeah.
Uh-huh.
Yeah.
Okay, piece of cake?
Yeah.
Yeah, good. So I don't even have to show you my periodic table.
I
See,
think I need
tag
to.
team, look at that. It took teamwork to get it. But you guys got it. You did pretty well. Okay, now this is what your exam is going to be like, you know? So it's not going to be some of the ones that are already on the polyatomic ion table. This is 1A. We want you to use your heads, concepts, think about it, big picture, right? Oxygen ions, they always have oxygens and they end with 8 and they have some other element in front of it, right? 8, ite, or ite, or per 8.
And
Right?
you don't use your Greek prefixes unless it's a non-metal, right?
Yep. So if it's all nonmetals all together, let's say like this. So if it's all nonmetals together, we know that that's a covalent bond. Here we get a chance to use the Greek prefixes. Hold on one second.
Where'd he go?
Oh, y'all noticed that too?
You ran away.
You're right.
He just like disappeared. So it's like class dismissed or?
No, he said he would come back. There he
Oh,
is.
okay.
Yeah, I wasn't running away. You can't get rid of me.
Is it
Drag me out kicking
dicarbonate?
and screaming. Okay, are you guys ready? What was the first answer?
Is it dicarbonate?
Dicarbonate? Nope.
No, it's dicarbon oxide.
Yeah.
Okay, so it's dicarbon oxide. Okay, so we want to remember when it's only nonmetals, right? And they don't have a charge associated with them. They're not ions, so they're not going to have that 8 associated with it. Okay, so these are not ions. They're forming just covalent bonds. So that one would be dicarbon oxide. You want to put the Greek prefix di, tri, tetra, penta. You guys remember that from, I don't know, when did you guys learn in math, right? You should have learned it in math. Are you guys freezing or is it just me?
Like cold?
What was that?
Freezing cold?
Not freezing cold as in your screen freezing, right? Because it
Little
sounds
bit.
like, you know, all of a sudden I don't even hear a pen drop. It's like nothing, you know?
Every now and then it'll freeze, but I mean, it'll kick back on.
Okay. Okay, so when we're doing nonmetals, all nonmetals together, there's no charge associated with it, or it's not with a metal, because that metal means that there's a charge going on there somewhere, then we know that we're going to be using the Greek prefixes. So that's going to be your di, tri, tetra. You guys remember that?
Yeah.
You should know all the way up to 10. Actually, you should know to 11. Undeca, that's 11. Dodeca would be 12. Trideca, that'll be 13. Okay, are you guys ready? What is this guy? Now, if you don't know this, I'm going to throw something at you through the computer.
Carbon dioxide.
Okay. So, and that's what you want to sit there and think about. I always use carbon dioxide to remind myself, oh yeah, these are all nonmetals. Carbon dioxide, oh, come on, really, I got that one, right? Okay, and the last one.
So it's dinitrogen tricarbon fluoride.
Fluoride. Excellent. So, piece of cake, you got it?
C.
So who's gonna do shimmy? You know, since they got it, they feel so confident.
Oh, I'm still gonna be cursing myself.
Hell, okay.
I got it right now, and then, yeah, no.
Okay, so feeling pretty good. That's the basis of nomenclature. So this type of nomenclature is called IUPAC nomenclature. So we use IUPAC nomenclature for this. We also have another form of nomenclature for organic chemistry. We're going to talk about that a little bit, but not yet. I promise to get to that. I am going to talk about it just a little bit this section. We're going to talk a lot more towards the second half. Okay? You guys good? You feeling overwhelmed? Let's see, who's here? Who can I pick on? Who haven't I heard anything? Oscar!
I knew it.
Man,
What happened?
we were talking noise about you. We were sitting there saying, Oscar, deadbeat. He hasn't been around. He doesn't give us any love. So,
Oh.
how you feeling on nomenclature? You got it?
For the most part, I have an idea, but I'm still not fully confident on it.
Okay. So what's going to make you confident? What do you need to do to be confident?
Practicing it more.
Practicing it more? You started
Yeah.
your homework? There should be a shitload of practice.
I know that.
Yep. So start your homework. Make sure you guys get it. And you will get so much practice, you're going to hate me. Almost. If you don't already.
I was about to say that.
Okay. So let's go. Let's keep moving, right? So you guys are feeling pretty good about this. So you've learned how to do metals and non-metals when they come together. So ionic bonds, remember that positive and negative coming together, those charges. You know how to do monatomic, right? When you have monatomic ionic bonds, right? So that's, and always remember, when do you use the Roman numerals? Maddie, since me and you always fight on this.
Ionic bonds?
Ionic bonds for
Is
what?
that what you're asking? Like ionic or covalent?
Well, yeah, that's true. It's ionic, but is it a particular? So do I just use them willy-nilly? I'm just going to put an I after carbon and an I after. When am I going to use it? Where does it
No.
belong?
Transitional metals?
Transitional metals, right? So you want to make sure that you understand what transitional metals are, and you should be able to identify your transitional metals. The post-transitional metals counts as well. We also use them for your post-transitional metals. Okay, Preston, when do I use the Greek prefixes?
Greek prefixes.
That's like di, tri, tetra, penta, octa, nona.
Use it with I think with a non-metal.
With non-metals, when we have only non-metals, yes. And you'll notice, like if you look at that dicarbon oxide, right? So you notice that first element, it doesn't get an "ide" at the end. "Ide" is kind of like putting a period at the end. It's like telling us that that's the end of the chemical. Because a lot of times what we'll do, we'll be typing up a list of chemicals, and we want to make sure that you understand that that is the end of it, okay? So, and that also kind of serves as a double purpose, because we also use "ide" when we're talking about the ionic component of it too, right? So if we have sodium oxide, so how would we write that? Sodium oxide. Let's see if I can. Now don't all you guys yell at me at once. Matt, been quiet. Sodium oxide.
Matt, you want to use a lifeline?
Sorry, hang on. Let me go back to my desk.
Would that, oh wait, no, I won't say it then.
Can anybody answer it?
Yeah.
Na2O.
Na2. Oh. Okay. So you notice here we have an ionic bond. It also serves to be the end for that. And so if you have just that element alone and it's not a polyatomic ion, we know that we're going to be using the I. Okay. So this is going to be important because we also have to learn how to name acid. acids are a special class of, well, I'm going to give you a very basic form of an acid, basic definition of an acid, and then that is going to change in the second semester. But for right now, we're going to give you a very, very basic definition of an acid. Okay. So you guys are familiar with this? You're feeling comfortable with this? If you're not feeling comfortable with this, hit your tutors up. You guys have ample tutors, and they've been complaining. They're like, yeah, I'm lucky if I get 2 people. They hardly come. They don't like us, you know? So you guys need to show them a little love and show up to their sessions and act like you like them, because they're sensitive to stuff like that. I'm not. So. Okay, you guys ready?
Yes.
Okay, so good. Now let's talk about an acid. Not the stuff that you drop at raves and stuff like that. We're not talking about that type of acid. Right, Maddie?
Right.
Okay, so acids are called proton donors, right? The reason why they're called proton donors is because they have the H+ ion, which we often will refer to as the hydronium ion. But if you guys ever look at the polyatomic ion table, the hydronium ion is actually written like this: H3O+. Okay, so I need to ask you guys a very important question. Have any of you guys had a clingy girlfriend or boyfriend?
Yes.
Wait, have you ever what?
Have you ever had a clingy girlfriend or boyfriend?
Oh, I thought you said, have you ever cleaned your boyfriend or
No, clingy, meaning that, you know, they won't let you go to the bathroom by yourself, or, you know, they want to be with you 24/7.
Oh, yes, I hate that.
Okay, so I know at least 2 people have had a clingy boyfriend or girlfriend, right? Anybody else? Nobody else
Yep.
have had that?
Oh yeah.
I
Okay,
have dogs.
okay, so you've had a clingy dog?
Plenty.
Plenty? Okay, so that'll work too. Okay, so you know how they're always by your side, they never want to let you go? Yeah?
Yeah.
Yeah.
Okay, so that's the whole part of being clingy, right? So H+ is kind of like a clingy boyfriend or girlfriend, and what it does, it's soon as it gets into a aqueous solution or water, right, it will cling on to the water molecule. So literally, this is what happens. So AQ means aqueous, it means water, in water, right? So, let me see. So what it does, it gets attached to the water molecule, and it just clings on, right? And that's the thing about it. That's what makes an acid sort of, kind of hard to deal with, and how it burns your skin, because it just wants to cling on to just about anything, right? So what happens is, it's like if you put phosphoric acid on you drop a little bit of phosphoric acid on your skin, it burns a hole through your skin because it's trying to cling on to that skin. Anything it gets attached to, it wants to try to cling on to, right? So water is available, since that's what's kind of making it its carrier. So it clings onto the water. Oh, I love you, I love you, I love you. I never want to let you go, right? Now it's going to cling on to water until it finds something that it feels worthy enough to let go, right? So that's kind of like a clingy boyfriend or girlfriend, right? And then they cling on to the next thing, right? So you get dumped and they cling on to that next boyfriend or the next boyfriend. Okay, so an acid is just what we call a proton donor. Why do you think it's called a proton donor? H+.
Donates the proton.
It donates a proton, because what's left in H+? Do we have an electron?
What'd you ask?
What's left in H+? Tell me, what is it made up of? The subatomic particles it's made up of. H+.
A proton, a neutron, and an electron.
Are you sure? You want to put money on that? Maddie, let's put
A
$10.
proton and an electron.
$20.
Change.
Are you sure? H plus.
It just has one proton.
It just has a proton. So we have one proton, that's it. That's all we have, right? So why do you think it's called a proton donor? Because it only has a proton to give. It doesn't have the electron anymore. It never had the neutron, right? So the only thing it can give you is a proton. It's giving you all that positive love, right? That clingy, positive love. Love you, love you, love you, right? Okay, so it clings to water and it forms what we call the hydronium ion. Okay, so that's the hydronium ion. And so often when we're talking about acids, because it's already clinging to water, we're talking about the hydronium ion. And then what happens is that H plus will exchange and jump onto the next guy that's available or the next girl that's available if it feels worthy enough to do that. Okay, and there's certain metals that it'll actually interact with to cause them to do certain things, right? Or there'll be certain anions that they'll interact with as well to cause them to do other things. Okay, you guys are with me so far?
Yeah.
Okay, so
Oh, yeah.
that's an acid. And you guys heard of pH before, right?
Yes.
pH. So pH
Balance.
is what we use to sit there and determine whether something is an acid or if it's a base, right? So all that is based upon the concentration of the hydronium ion. So it's minus the log. And we haven't talked about concentration, but that's our next topic. Concentration of the hydronium ion. And that just happens to equate exactly with just H plus, okay? So often, because we're chemists and we like to keep things simple, and we like our equations to kind of be just as simple as we are, we will often just write H plus aqueous. And that will be the same thing as the hydronium ion. Okay, are you with me?
Yeah.
Okay, good. So keep this in the back of your mind because we're going to be using it in about a week or so, maybe even less. Okay. Here. Okay, so now let's talk about naming acids. But I still need to kind of explain to you how it kind of works, right? So we have solutions like this. There are two types of acids. We have what we call weak acids and what we call strong acids. So if you just see HCl and it doesn't have anything next to it, you're going to make the assumption, your first assumption is it's going to be two nonmetals, right? Because hydrogen is really a nonmetal, right? Is it not?
Yeah.
Okay, so our first instinct is to say, if you see HCl, we're going to call that guy, we're going to name it, what will we name it?
Hydrogen chloride.
Hydrogen, I could spell, hydrogen chloride. Okay, so our first instinct would say this is hydrogen chloride, right? Because it's two nonmetals together. Okay, so we need to make a distinction that we're talking about hydrogen chloride gas or hydrochloric or hydrochloric acid, okay? So the way that we make that distinction is by putting a G to let us know that we're talking about the gas, okay? So if you have H Cl, AQ, that means that we're talking about the acid, because acids are going to be aqueous. So what happens is, let me tell you how it's typically made. We take hydrochloric gas and we bubble it into water. And so as soon as you start bubbling into water, the hydrogen becomes clingy and binds to the water, right? It leaves the chlorine and forms an ion. So it becomes H plus binding to water. So you end up with, and this is what you actually end up with, and I will show you another notation to kind of help us minimizing keeping track of the water, because water is infinite. Since the fact that we have aqueous, we have a lot of water, right? This is what you'll see. This is what actually happens. And then I'll show you the way that we write it to make it easy for us. So hydrochloric acid, and I'll type this out for you too, so you'll know, is a strong acid. And you're going to ask me at some point, what's a strong acid and what's a weak acid, and why is it strong and why is it weak? I'll explain that to you here in a second too. Okay, so this is the way that it really happens. This is what really happens. This is what we write to make it easy for ourselves, because it's easier to track the H pluses this way. That's the main reason. And you'll see books, you'll notice every book written, they'll go between the two spaces every time. So you'll see it written one way on one question and then another way on another question, but it essentially means the same thing. Okay, so let me explain to you why hydrochloric acid is a strong acid. Hydrochloric is a strong acid because as soon as it hits the water, as soon as you start bubbling that gas into the water, it separates into the ionic components. You will have your H plus and you'll have your Cl minus. They form immediately, and they'll stay that way. They'll stay separated in water because water is that home wrecker, and that H plus is already clinging onto water. It dumped chlorine for water. You know, it said, hey, water's hot, you know? So that's what's happening there, okay? And it happens instantaneously. So acids, strong acids will separate instantaneously, right? You're gonna see the majority of them will be in this form. 99.9% of them will look like this. Only a small percentage of it will look like this in solution, okay? Very, very small, like 0.01%, okay? Are you with me?
Yep.
Okay, good. Okay, so strong acid. And so this acid here is going to be called
Hydrochloric acid.
hydrochloric. So I'm going to teach you a little. Hydrochloric acid. I'm going to teach you a little rhyme to kind of help you remember. So my ride has high, and it's spelled wrong, I know, hydraulics. Oops. Okay. IDE. So if you have chloride, you're going to use hydro and IC at the end, okay? So we know that this is chloride, so the acid would be just, this is a chloride with the hydrogen, so then that's what you're going to get over here, a chloride ion. So this guy is called hydrochloric acid. The ion that's made is chloride. And a hydronium ion. Okay? Do you guys get that? Okay, I'm going to test this out for you. My ride has hydraulics. Okay? Hydroic. So we have chloride over here. So this acid is going to be called hydrochloric acid. Okay? So let's say if we have this guy. Okay, what is that guy going to be called?
Hydrosulfuric acid.
That is correct. Okay, piece of cake. What about this one?
Hydrophosphoric acid.
Okay. Okay, piece of cake.
Yep.
Are you with me, Oscar?
Yeah, I'm still here.
You're still here? Good. I know you're tired because I know you got off of work. So your eyes are like, you know, you're putting in the toothpicks right now. So,
No, I'm just taking notes.
okay. Okay, so you got the handle of this. So let me give you another little saying, okay? So my ride has hydraulics. I ate organic apples despite them being poisonous. I ate organic apples despite them being poisonous. Okay, you're like, what the hell is this, right? So if our anion is an 8 that we get from our acid, then we use IC an acid. If it's our anion is an 8, then we use OUS acid. So let me give you an example. Okay. What is this anion called? This guy over here. SO4 2 minus.
Sulfate.
Okay. So that's the sulfate ion. So that means this acid is going to be called
Sulfuric acid.
And we know what this ion is called, right? What is this ion called again? The H+.
Hydrogen.
You can call it the hydrogen ion, but typically we call it the
Hydronium.
hydronium. Okay. Although really the hydronium is the H3O plus. Okay, so are we good? You got it? So if I have this guy, what is it called?
Sulfite.
Okay, so it's called
Sulfite
sulfite.
ion.
Okay, we know that this one is the hydronium still. And then this guy, the acid is going to be called what? ITE.
Sulfurous.
Sulfurous. Yes, that's right. Sulfurous. Sulfurous. Acid. Okay, piece of cake. Simple. Tia,
Mm-hmm.
you with me?
Yeah.
Who's MC? Is that Mauricio?
Yeah, that's me, Dr. Henry. I got kicked out like 8 times already.
This program loves you.
It does, honestly.
Yeah. Okay. So you can see if it's ITE, if the anion that's forming is ITE, we're going to be using OUS acid. And if it's an ATE, we're going to be using an IC acid. Okay, sulfuric acid. Right? You got it? You want to test it out? Excellent. You guys are so exciting. So we're going to sit there. You guys know it already, right? That's my understanding. We should move on.
No.
Let's test it.
Oh, we should test it. Okay, I just want to be sure. Okay, so let's say we have, let's change this up here. Okay, what if we have these guys? What is the anion called? And what is the acid called?
Is it hyposulfite ion?
Okay. Okay, so then the acid is going to be called, oops, I'm sorry, is it hyposulfite for that first one? Sorry, my bad.
I was talking about the one on the bottom.
Second one. Okay.
Wouldn't that one be wait.
So the top one would be hyper sulfate or sulfite.
Is it hyper or do we use something else?
Per.
Per, that's
Okay.
right. So it'd be persulfate ion. Okay, so then what would we call this acid?
Is that persulfuric acid?
Persulfuric acid. That's right. And then what do we call this acid?
Hyposulfuric.
Is it ick? Isn't it an IT? What does that say? Despite being poisonous.
Hyposulfurous acid.
That's right. Okay. Erica, you there?
Yeah.
So what do you think, Erica?
About the answer?
Yeah. Do you agree?
Yeah.
Yeah?
Yeah, I do.
Okay, that is correct. Okay, so let's see. You guys ready to test it out? So I'm going to just start throwing acids at you like crazy. And you guys are going to be ready to answer. You ready? Yeah?
Yeah.
Yeah.
Okay. Let's see. Okay, you guys got the little anagram down? Both of them?
Yes.
Okay. Good. Okay, so let's go. Okay, so let's go with the first one. What is that guy called?
Hydroperphosphoric?
Hydro?
No, not hydro. It's just perphosphoric acid.
Perforic acid. That is correct. So, that reminds me. Let me give you another example here. Let's call this. Okay. So the next one.
Hypochlorous acid.
The next one.
Boric acid.
Okay. This guy a little space. This guy here.
Would this be dihydrogen phosphite? Or no? Dihydrogenous phosphite?
Is that an aqueous or is it a gas? And remember, this is P, capital P, lowercase o. Is capital P, lowercase o, phosphate or phosphorus?
No.
I like this one because it always throws people on it shakes them up because they're not used to seeing PO.
It's that plutonium or whatever it's called.
Ammonium. Okay, so then what would we call this? Where's polonium located?
16. So yeah, big. Right.
Don't overthink it. Kayla, are you there?
Yep.
What do you think?
I think I don't really know.
Darlene, what do you think? Now you said, I heard Cassie say it's in group 16. So what do we know? Who else is in group 16?
Sulfurous, so it'd be the right? Fluonic acid?
It would be what? Per? You said per?
No. Fluonic acid,
Polonic acid?
right? Or no? Because
Oh, you're almost there. Because how many sulfuric acid has how many oxygens?
has how many oxygens?
Mm-hmm. How do we write sulfuric acid? What is the chemical formula for sulfuric acid?
Just so two.
Tell me the chemical formula for sulfuric acid. You can do this.
HSO2.
Say it again.
HSO2.
Sulfuric acid.
No, that's not right.
H2SO4.
H2SO4. So sulfuric acid is H2SO4 AQ. So polonic acid would be what?
So this is per.
That's right. So it'd be per polonic. Oops. Eventually, my fingers will actually start working this morning. Okay, propylonic acid. Piece of cake?
That was a hard one.
Look, it's that PO that throws everybody off because your first thing is to see that P and you think phosphorus. I know it's phosphorus, right? And then you're looking and you're like, oh, that's a small lowercase o. Wait a minute, hold on, let me take a step back, right? So it's really important to pay attention to whether it's capital or lowercase. Okay, what about this guy? NH3. So this is a setup answer because this is just aqueous ammonia.
So there's no such thing as an ammonious atom?
Yeah.
Okay, because that's following the rules, right? Because it's minus.
Yeah.
Subtracting, so it'd be an I, which would make it a us.
Yeah. So normally, yeah, you would say call it ammonious atom or yeah.
Okay.
Not ammonious. You would call it ammonic. You are not ammonic. You would call it nitric acid, right? But it's really, or sorry, hydronitric acid. But hydronitric acid doesn't exist. It's ammonia.
Okay.
Okay. What about this? I should say the name doesn't exist. This guy right here.
Of which one?
Right here.
Oh, that one.
Just phosphoric acid?
Phosphoric acid.
Or phosphoric, sorry.
But is it just phosphoric acid? There should be something in front.
Hydro.
Hydrophosphoric acid. Remember, if it doesn't have an oxygen, you're going to put hydro. That lets us know that there's no oxygen there. Okay. And then the last one. H2O. What is H2O in water? Come on. I know you guys can do this. What is H2O in water?
It's water.
It's water. That's right. It's water. That's the answer. Oops. Okay, you guys got it? Piece of cake? And I guarantee you're going to see at least ammonia or water on the exam too. So those are my curveballs.
You said
Okay.
if it has an O, we're using hydro, like oxygen.
No, if it doesn't have an O, right? You notice all the ones that don't have O, they have hydro in front of them. Well, we only have one example up here, right? All the other ones have O's. So they're going to be either ic or OUS. There's no hydro in front of those, right? The only one that has hydro in front of it is the one that doesn't have oxygen. So if it's H2S, then we know it's hydrosulfuric acid. Remember? And if you just think about it, my ride, IDE, and that doesn't have oxygen in it, has hydraulics. Except. Okay?
Okay.
Okay. So I will see you guys Wednesday. No lab today.